Now we're recording. This is day 1 of fractions. Recorded live in Mrs. Juergen's room 204. All right, so you guys, the first thing we're going to talk about is why we cannot add or subtract denominators. So we're gonna go through addition, subtraction, and multiplication really quickly. We're doing addition and subtraction today. We're doing multiplication tomorrow. Then we're going to start on division, and we do a couple days of division of fractions because that's the new thing that you guys haven't really learned yet. Okay, but let's talk about why we can't add or subtract denominators. And before we do that, tell me what you remember about fractions. So specifically, what is a fraction? Mark?
It's a more expanded version of percentages almost.
You know what? Percentages is a special type of fraction. So what's just a fraction? Caitlin? Parts of a number. Okay, Allie, what do you say?
A part of a whole.
A part of a whole. That's the one I was looking for. Okay, I know that you all already know this because I know that you learned adding and subtracting of fractions in 4th grade, but we're going to just refresh our memories really quick about why it doesn't work to add or subtract denominators. Okay, so let's take a look at this fraction up here. And we're actually going to model this. You don't have room on your notes to do this, so you can just follow along up here. But a fraction is a part of a whole. And when we have a fraction, the denominator tells us how many parts the whole is cut into, right? Everybody's with me on the same page with that? So up here I have a whole rectangle cut into 8 parts because I have denominators of eighths up there. And I'm going to take 4 of those. The numerator tells us how many of parts we're talking about. And I'm going to shade them like that. So that represents my first fraction. And I'm going to add to it 3/8. And I'm going to cross-hatch them like that to represent my second fraction. So 4/8 plus 3/8. Now how many eighths do I have? Darren?
7/8.
Yeah. So that equals 7/8. Okay. Now let's just look at why it doesn't equal 7/16. Since the denominator tells us how many parts the whole is cut into, so let's take a look at this. So here are eighths again, right? And instead of this equal, I'm going to draw a does not equal. That sign, you guys, by the way, represents does not equal. When there's a little diagonal line through the equal sign, that means no thank you. Okay, so if I were to, for example, add both my numerator and my denominator, I would end up with something that looks like this, right? 7/16. I know you all know that that's bad math, right? Can I get some yes, man? Just kidding. I'm just kidding. Can I get some hi, yes? No. All right. So let's take a look at what happens when we do that. When we say that the denominator now equals 16, what we did is we just cut our whole into different sized pieces. And instead of adding 4 of them, like this, plus another 3, we just added 4/16 plus 3/16. It just doesn't work, right? Like this shaded part does not match up with that shaded part, does it? No, so that doesn't work. So no one's going to be trying to add or subtract denominators, right? All right, then let's go ahead and move on. I just paused it there for a second. You're going to have some definitions. So on your notes, a fraction is a number on the number line that is less than one whole number. Allie said it really well too. It's a part of a whole. So if we have a number line, yeah, go ahead and write that definition next to fraction on your notes. If we have a number line, this is 1, this is 0. Fractions exist somewhere along there. For example, probably right about here would be about 2/3.
Wow.
And right about here would be 4/5. Okay? All on the same page with that?
Yeah.
Does everybody have the definition down?
Yes.
Okay. An improper fraction is a fraction in which the numerator is greater than the denominator, and those are going to be greater than 1. So an improper fraction exists somewhere over here to the right of 1. Let's see, for example, 8/5 might be right about here. Oops. And 12/7 would probably be somewhere over here, because that's almost 2, right? Because 14/7 would equal 2. Okay. A mixed number is a number consisting of a whole number and a fraction. So for example, the one that we have up there, would look like this on the number line. Oh, actually it would look like this. 2 2/3, or this would be 3. So it's almost 3 more than 2. So those are the terms that we're going to need to make sure that we know and understand in this unit. Camilla?
If you have like 5/8 plus 3/8 and 8/8, would you just write 1?
You would. So Camilla asked if you have 5/8 plus 3/8 and it equals 8/8, would you just write 1? Yes. Because another thing that you're going to remember in this unit is that we will always simplify. Okay, so we'll always simplify the fractions and we'll always change improper fractions to mixed numbers. There might be a few exceptions, but not very many. In this unit, we're going to avoid decimals. Okay, we are not going to change any problems into decimals. We're going to keep them in fractions. And then I want you to write this down too. The key to adding and subtracting fractions is a common denominator. Darren? I did. I have a spelling error. Denominator. Much better. Jake?
So today will we be learning how to make a common denominator?
We're going to
like 5/8 plus 3/6.
Yeah, so we are going to do that today, and you've done it before, so it's not new. So we're going to review that for today. Have on your sheet. All right, so we're going to add those two quantities. We have 3/4 and 2/4. We are only going to add the numerators, so we're going to end up with 5/4, right? Because 3 plus 2 is 5. Now, what do I have here in front of me? What kind of thing that we just talked about? Cora?
You have an improper fraction.
Yeah, so I'm going to change that to a mixed number. I'm going to rename it. When you guys were in 5th and 4th grade, you did something that looked like this. You renamed it into one whole, so that would be 4/4, or however many wholes you can make out of that improper fraction, right? And then you put the second one over here, the remainder. Okay, so that 4/4 are going to equal 1 and 1/4. Allie?
So in this unit, will you ever want us to keep it as
an improper fraction? I don't think that we ever have any problems where we'll keep it as improper fractions. The only time you might do that is like in the middle of a word problem when you're still working. Then you can keep it as an improper fraction. But when you simplify, then you're going to need to change it to a mixed number. Jill?
So can you just divide 5 by 4?
Can you divide 5 by 4? So yes, but we are not using decimals in this unit at all. But yes, technically that's a division problem, 5 divided by 4. But we're
how I did it, I got 1 and then 4.
We've got 1/2 and 7/8. What do you notice about those two fractions? Camilla?
The denominator is
Yeah, the denominator is different. We need to change one to the other, right? Or find a lowest common denominator. And since 8 is a multiple of 2, I can change that 1/2 to be an 8 really easily, can't I? So I'm going to, actually, let me erase that and write my whole thought process here. So I'm going to multiply both the numerator and the denominator by 4. So I'm finding an equivalent fraction, and I'm going to write 4/8. So now I have 4/8 plus 7/8, and 4 plus 7 is 11. I have 11/8. So I'm going to rename that, into 8/8, plus 3/8. So my answer is going to be 1 and 3/8. Okay, now let's take this one. We've got two mixed numbers, don't we? Now what we can do with this is we can add the fractions first, just like when we're doing multi-digit addition and we have to regroup, or not regroup, but compose new numbers, right, or carry. We're going to do that here. So here we have 5/8 plus 3/8. So let's add 5 plus 3. We get 8/8, right? Okay, let's just leave it like that for a minute. And then we add 2 plus 3, and we have 5. So we have 5 and 8/8. So when I simplify this fraction, that 8/8 needs to go, right? Because that's one whole. So let's just add it onto the 5, and we'll write 6. And that's going to be our answer. All right, let's review subtraction really quick. So flip to the next page. And you guys are going to have plenty of problems to do on your own, so don't worry. Okay. You know what I'd like you to do is let's rewrite this first problem right here because it's in the wrong order. Because we're going to end up with a negative number and we haven't learned those yet. So let's do 2/4 minus 1/4. Okay. So just cross this off. We are, but not until our graphs unit. So we have a little ways to go. Okay, so now I'm just going to do the same thing except subtract. So 2 minus 1 is 1. And I leave the denominator as is. And I get 1/4. Okay. Now I've got a tricky one here. I've got 56 minus 7/8. I can't really take 7/8 away from 56 very well, right? I need to rename this number. I'm going to decompose it and get some eighths for myself that I can subtract that 7/8 from. Do you know how to do that, Evie?
No, it's just that on our paper, we have 5.56. Yeah.
That's the number. So it's number 5.
Oh.
That's okay. All right, so let's rename this 56 and let's write 55 and 8/8. Is that the same number? Is that the same number as 56? Yes or no, guys?
Yes.
Yeah. Now I can take 7/8 away from that 8/8, right? So let's do that. So I'm going to subtract 7/8 from 8/8, and I'm going to get 1/8. And then I have that 55. So I'm going to write that, and that's my answer. Okay, over here we've got 2 mixed numbers, so at least a little bit easier. But we've got 2 different denominators. Oh, goodness. Jill.
Should we flip them around?
We're not going to flip this around because this is 82 minus 22, and like 82 and a half minus 22 and a half, or 15/16. So since this is less, we're going to be fine. We're not going to end up with a negative number. But what we do need to do is change this denominator. Miranda.
Multiply 1/2 times 8/8.
Awesome. Okay, so let's do that. Let's multiply the 1/2 times 8/8. And we're going to get 82 and 8.
What?
That's weird.
Is it what?
We have to do one more thing, don't we? Because we've got 8/16 up here and we've got 15/16 down here. Caitlin.
You would take 82 and make it 81 and add 16.
Okay. Yep. So I need to take 16/16 out of there, right? And it would look something like this. 81 and 16/16 plus 8/16. I know. We're taking one whole out of the 82 and we're renaming that fraction. So now I'm going to get 81, and if I add 8 and 16, I'm going to get 24/16, right?
What?
Yeah?
Yeah.
Yes, it is. Okay, so the reason I'm doing that, you guys, is because I didn't have enough 16ths to take away 15 from. So now I can take away 15, so I can take 15 away from that 24 and end up with a fraction. But you know what I'm going to do is I'm going to actually rewrite this entire thing. So let's rewrite it below down here. 81 and 24/16 minus 22 and 15/16. Now it's much easier. All right, let's take 15 away from 24. What do we get? Come on, guys. Miranda. Let's deal with our fraction first and take 15 away from 24. Oh, that's okay. So if I subtract 15 from 24, I'm going to get 9. And then I'm going to subtract 22 from 81. And I'm going to get, not the Toyos yet, 9. 7 minus 2 is 5. So 59 and 9/16. Now did I do it wrong? Did I make a mistake? Oh, good. Okay, what, Janessa?
I'm confused on how you got 24.
Okay, because, all right, you guys, that's okay. So up here, what I did was, since I had 82 and 8/16 right here, I'm not going to be able to subtract 15/16 from 8/16, right? Because 15 is greater than 8. So I need a number up here in my numerator that's greater than 15. So I renamed that 82 and I took